57, we're going to be finding the least common multiple of algebraic expressions. Now, this is important because a least common multiple is also called what? No, it's not a greatest common factor. It's the least common denominator also, right? So if you'll kind of recall back to the very beginning of the class, what have I been just really lecturing you guys on? When you come up on an equation that has fractions in it, you're going to get rid of it by multiplying through by a common denominator. Now, we don't have to use the least common denominator, but we have to use a common denominator. And the same thing is going to be true when you have a fractional equation, a rational equation, which is an equation that has variables in the denominator. If you have an equation that has variables in the denominator, we're going to find an LCM, common denominator between those variables, and we're going to multiply through by that algebraic expression, and things will cancel and the fractions will go away. So this skill, all we're doing today is learning a skill. Well, what is algebra? Branch of mathematics. The skills necessary to solve all types of equations, right? So we're learning a skill here that ultimately we're going to use to solve equations, okay? So we're going to find the least common multiple of algebraic expressions. We're going to first review ourselves of what the least common multiple is, all right? So the process, the first thing we're going to always do is write each number or expression, it's not necessarily a number, as a product of prime factors. Now, what this means is we're going to factor the expressions. First step is going to be factor the expressions involved. All right, not expressions, expressions. All right. If it's numbers, we're going to factor them as prime factorization. If they're algebraic expressions, then we're going to do what we just did, number 4 and 5. We're going to factor out a GCF from our algebraic expression. Okay? Then we're going to use every factor. The least common multiple has to have every factor of the giving numbers has to be a factor of the LCM. So if the number has a 2 in it, then the LCM has to have a 2 in it. If the number has a 3x in it, then the LCM has to have a 3x in it. If the expression has an x plus 2 in it, then the LCM has to have an x plus 2 in it. So every factor of the given number or expression has to be a factor of the LCM. Okay? Then we're going to use each factor in the LCM. We're going to use each factor the greatest number of times that it is a factor of any of the numbers or expressions. Okay? That's confusing. So let's just start off with something like this. Let's just suppose that we were working with this number. 2 times x squared times y cubed. And then our other expression is 3 times 2 squared times x to the 4th times y times z. That's 2 factored expressions, right? So my LCM is going to have, tell me what my LCM has to have in it. Based on this first thing, every factor has to be a factor of the LCM. So I've got to have a what? A 2. I got to have a 3, right? Because there's a 3. I've got to have an x. I've got to have a y. And I've got to have a z. Now, the second part says use each factor in the LCM the greatest number of times that it's a factor of any of the numbers. So what's the greatest power of 2? Squared. 2 squared. What's the greatest? There's only 3 to the first. So 3 to the first, I'm good. What about x? X to the 4th or x squared? 4th. You have to use the biggest one. All right? Y to the 3rd and z to the 1st. So this would be the LCM. And of course, we could multiply it back out. That would be 27x to the 4th y cubed z. So finding the LCM, you have to use each factor the greatest number of times that it's used as a factor in one of our expressions. All right, so it's a little confusing to describe the scenario. You just have to practice it a couple times to see what it's going to look like. All right, so let's do it with just regular numbers, and we're going to follow the rules. So we're going to factor 24, and we're going to factor 36. What's the factorization of 24? It's 8 times 3, right? Which we could write as 2 times 2 times 2 times 3. 2 to the third times, not 8, times 3. Okay? Everybody agree with that? Is that a factorization? Now, you could write it out if you want to. You can use exponents if you want to. We've been doing that all along. Now, 36 is 9 times 4, which is 3 squared times 2 squared. Right? So my LCM has to have a 2 and a 3. It has to have 2 3 times and 3 twice. So my LCM is 72. It's not too bad, right? You just have to learn how to follow the rules. LCM is 72. Karis? I don't know. I'm doing this to teach you the process, and for me, process is more important than answer. So until you get used to doing it with algebraic expressions, let's follow the process. So 11 is prime, right? So it's 11. That's the prime factorization of 11. 12 is 2 squared times 3. And 18 is 2 times 3 squared. Right? So my LCM has to have what numbers as factors? 2, 3, I don't need a comma there. 2, 3, and 11. How many 2's do I need? 2. You have to have the greatest, right? 3 squared, and then 11. So that's going to be 44 times 9. 360 plus 36, 396. Is that right? 396. So I'm not sure what method you would use to find that if you didn't use the process. How would you find the LCM of these numbers without doing the factorization? Okay. You were just... Okay. I thought you had another method you were using, which would be fine if it's a good method. Don't poke yourself in the eye. All right? Y'all okay with that? So that's how we would find the LCM of a numerical expression. Well, let's talk about what this would look like. It's going to be the same process. What are the factors of 10a squared c to the fourth? 5 times 2, yeah, a squared c to the fourth. We don't have to expand that. Right? What's 15 going to be? 3 times 5, a to the third, c to the third. So my LCM is going to have, let's just do 2, 3, 5. 2's only used once, 3's only used once, 5's only used once in our terms, right? A to the third, c to the fourth. So 6 times 5 is 30, a cubed, c to the fourth is our LCM. Good? All right, it gets a little more complicated, but not much. Try this one on your own, see what you come up with. So 6 would be 2 times 3, p squared, s cubed. The second term is just 2m squared, s squared. 8 is 2 cubed, m cubed, p. Right? So my LCM has to have what factors? Has to have a 2 to the third. It has to have a 3. It has to have an m to the third. P squared, s to the third. So we'll keep our variables in alphabetical order. Just, you don't have to, but it's just common. It's proper. All right. So 24 m cubed p squared s to the third. All right. Y'all okay with that? It's up the game. The least common multiple of these two algebraic expressions. We're going to factor each one if they're factorable. Okay? Can 3x plus 1 be factored? Is there a GCF in 3x plus 1? So 3x plus 1 is it can't be factored. It's prime, so to speak. It's a prime expression. So 3x plus 1. Does 2x plus 9 have a factorization? No. So what's the least common multiple of two prime expressions? It's just the product of those two expressions. So my LCM here is just 3x plus 1 times 2x plus 9.
Would you want us to
Have we done that?
Yes, we
In this year? We haven't done that this year yet.
Not this year. We did it last
You
year.
did 3x times 2x
Yeah.
and then 3x times 9.
Yeah.
And then 1 times
Yeah, I mean, you did it last year. We haven't done it this year. And y'all listen. Yes, you did. And listen, we're off track. You need to, more often than not, in algebraic applications of this, you're going to leave the LCM unmultiplied. Leave it in factored form because it's going to be more useful to you that way. All right. Next one. This one, we've got some factoring to do, don't we? So the factorization of the first one, let me give y'all a second to write it down. You need to write this down. This is where it gets, a little bit tricky and difficult. What is the factorization of 7x squared plus 21x? 7x times x plus 3. What are the factors of that expression? 7, x, and x plus 3. Remember, the parentheses is one thing. Okay? What's the factorization of 6x plus 18? 6 times x plus 3. So my LCM has to have the one of every factor that's being represented here, right? So I need a 7. I need a 6. I don't need to factor 6 because it's relatively prime to 7. I need an x, and I need an x plus 3 only once. So my LCM is 42x times x plus 3. I don't want you to. I want you to leave it in factored form.
Thank you.
If you multiplied it together, it wouldn't be incorrect, but it's not as useful to you, right? That's right. We're going to use this in factored form more often than not when we actually start working with these things. Try this one on your own. Okay, what is the factorization? We're going to finish this. What is the factorization of 60x cubed plus, we can take out a 12x, right? That leaves us with 5x squared plus 2. In the second expression, we can take out a 9x squared, and that leaves us with 5x squared plus 2.
I didn't see the 12x opportunity.
All right, y'all stay with me, please. Stop. Everybody stop. You're going to be okay. Now, the LCM here, what we need, what's the LCM between 9 and 12? 36, right? I need a factor of x. How many factors of x do I need? X squared. And then I need a 5x squared plus 2. So that is the correct answer. All right? Your homework is 372, A through G, 1 through 11, 13, 15 through 18, 21 through 25, and 28. Sorry for keeping you late, guys.